What is up, YouTube? Today we are doing part 9 of my homemade lathe. Now, I got the carriage technically done. It works. Everything's here, everything's assembled. I am, like I said in the last video, I am kind of tempted to rebuild my compound slide or compound rest, whatever you want to call it. I'm kind of tempted to rebuild it because it's a little small, doesn't work that well, and I kind of designed it wrong, but I may be able to improve it a little bit. But first, today in this video, what I'm going to do is rebuild, can't see me, rebuild the headstock. You still can't see me. Damn. There we go. There we go. We're gonna rebuild the headstock. As I was turning a piece of metal, I was realizing the chatter that I keep talking about is not in the tool. It's not in the carriage. It's actually in the headstock. So when I was taking a deep cut, you can see this entire headstock just bouncing up and down really fast. So we're going to replace it. I've been planning on replacing it, and I found some much better, much bigger axle, I guess you could say. I guess you could call it an axle. I don't know. For my purposes, I'm just going to call it an axle. So this is 1-inch diameter axle, and I found at the scrapyard a 2-inch diameter axle for this. So let me show you what it looks like compared to this size. Alright, so this is the original headstock. I have a 1-inch case hardened axle, which means that it's hard on the outside but soft on the inside, which means it's able to flex. That is not what I need. I need a completely hardened axle, and this is way too small. So I am replacing it with this. This is a 2-inch, I believe it's completely hardened axle. This is definitely big enough for what I need. This thing is mammoth. These bearings are huge. I'm not entirely sure how much these bearings would be, but 2-inch diameter, inner diameter bearings online are like between $100 and $170. So I bought all this stuff for $15, which is amazing. So this will work perfectly. But before I start cutting that off, we need to turn this piece so this will be able to slide onto here, because this is going to be the new pulley for the headstock. So I'm going to be using this because this slides onto the axle. I'm going to cut this off right here and then put it on the lathe, mill it down, or turn it down, and also turn the hole bigger on here, so therefore this can slide onto here, and that will be the new pulley for the headstock. Alright, so I turned this piece down, so therefore this hub can fit on there. Now I'm not entirely sure how well this is going to cut, because I believe it is cast steel, so not really sure how well it's going to turn, but we're going to find out. Wow, this thing cuts horribly. Damn, look at that. I guess it's time to break out the file. Alright, so we got this piece done. It actually looks pretty decent. I had to definitely clean it up with some files because it had some really bad chatter. So, but now it looks pretty decent. Looks like it's going to work. A little bit of a change of plans with the pulleys that I'm going to use. And I was originally going to use this, and I cut a groove where I would need to cut the hole for it to work for that. And as you can see, it's not going to work because I can't drill holes along here. And you know, it's not going to work. It's plus it kind of looks ugly with all these ridges and stuff. So we're going to use this one. This is off of a riding lawnmower, and it will look a lot better. It's 1 inch bigger, which is like 1 or 2 or 3 inches bigger than the pulley that I originally wanted to use. But it's better than going and buying one. So this was free, I already had it, and it will work a lot better for that. Alright, so let's mount this onto here, and then grind in a groove where I'm going to need to cut this. Let's also make sure that this is running true. Damn, that's good. That looks awesome. Small. See, this thing doesn't really have that much power. That's why I'm putting a bigger pulley on here. It's going to go slower, but it is going to have more power, which is better. That is perfect right there. So, I could either try and part it off with this giant tool right here, or I wonder if my bandsaw would cut it. I'm going to try and see if it'll cut on my bandsaw. It's pretty thin. Alright, so I'm trying to cut this with my scroll saw, and it's actually working. I'm actually really surprised. There's just a really dull blade on here, and it's actually cutting metal, so it's actually working. Yay! That took forever. Alright, so now we got the pulley mounted to the hub. Now it's able to slide on. It's a tight fit. Works perfectly. There's pretty much perfectly true. And also I have 2 set screws there and there that I can tighten down, and it'll clamp down on here. I'm pretty sure I'm not going to do a keyway because really there's not going to be that much force pulling on this, and I don't have a keyway on this one. I just have 2 set screws holding this on, and it's not slipped so far. Worst case scenario, I drill little pilot holes for the set screws to sit into. So now that we have that, Now what we have to do is cut this out with the angle grinder and cut the middle out with something. I have no idea how I'm going to do that. Turn it down to where it's 5 inches in diameter by 2 inches inner diameter. So therefore we can slide this onto this end, and therefore I will have a place to mount the chuck. So should be easy. Just cut it out with the angle grinder and then turn it on the lathe. There we go. Definitely not the easiest way to make a hole through something, but if you don't have the right tools, all you need, drill bit, hammer, and a chisel that you don't really care about. And it works really well. Alright, so I got the inner diameter to what I needed, so I flipped the jaws around on the chuck and I clamped it on the inside. Now I got to turn the outside diameter to what I need it to be, which is 5 inches. So shouldn't be that hard. I did have to grind it, so it is going to be a lot of chatter, so hopefully not too bad. Alright, that's pretty good. It's a little bit bigger than 5 inches, but it should be good enough. Oh yeah, wrong way. There we go. There it is. Let's see if it fits. Yep. Perfect. There it is. Alright, so we got these two parts done. I got the face plate for the chuck done. This is going to be going onto here, and this is going to be going on here, just like, hang on, just like that. It doesn't want to fit on right now, but it's going just right there. And tomorrow I'm going to be taking this to school and welding the crap out of this thing. I'm going to weld it on both sides, here and here. Really thick welds, make sure it's really strong. And then once I'm done, then I can finally take the small headstock off and figure out how in the world I'm going to mount that to the I-beam of the lathe. Alright, I was able to bring this part to my school, and I welded this piece using stick 7018. And pretty decent welds. Are definitely going to be strong enough. And 3 welds on this side and 2 welds on this side. Also, once I'm done, I will face this side and also face or do a pass on this side, so therefore it's perfectly true, because right now it's not. It has a little bit of wobble and it's slightly up and down, which is to be expected because I did weld it. Anyway, so I finally got that done. I also figured out how high I need to put this. I just finished cutting these extension blocks for the this piece, and tomorrow I'm going to be bringing this to my school and welding the whole thing out, cutting this piece off, this whole part off, and putting this on. So I also I added 1/2 inch to the height of this, because eventually I'm going to want to rebuild my compound slide, and to make it better I need to add another piece of plate, so therefore I can properly have this clamp onto here. So I'm gonna have to add another 1/2 inch piece of plate on here, so therefore I went ahead and already added another 1/2 inch to the height of this. So yeah, simple enough. I have to bring this to my school, which means unfortunately it's kind of late right now and I have to load this in my truck by myself with a bad back. So wish me luck. Hopefully I don't blow up my back. Alright, so we got the new headstock all welded up. It's really strong and it's perfect. So now all we have to do is get the bearings in there, get that thing in there, and put it on. And the hard part about this is, unfortunately, I'm gonna have to make it to where this thing is perfectly flat and also perfectly this way, you know, because when I do a cut this way, I don't want it to get smaller and smaller the farther I go out or the bigger I go out. So I need to make it exactly perfect along this plane right here. So therefore, when I do a long cut, it's not going to get bigger or smaller the farther out I go. So that's going to be definitely hard to do. But first things first, let's get the bearings. Get the giant axle, and let's put it on the headstock. Alright, now the really cool thing about these bearings is they're not normal bearings. With the normal bearing, you have the inside diameter of the bearing almost similar to the outside diameter of whatever axle it's designed for. With these, it has these collars, and the bearing is actually bigger than the axle it's designed for, but these collars, they actually have a taper on them, and the inside of the bearing has the similar taper, so therefore when you sit the collar into the bearing, you have threads on this side, and you have this giant weird looking nut, and when you tighten the nut, it basically tightens the collar onto the axle and also on the bearings. So these bearings are actually perfect for this application of what I need, which is awesome. I'm able to go to the scrapyard and actually buy a couple more, which is what I'm going to do hopefully soon, but it's kind of a nightmare to get to in the scrapyard, but they are definitely worth it. These are amazing. They're not cheap online. I haven't really found these bearings online, but I know bearings in general that are 2-inch inner diameter are upwards to 100 to 100 and something bucks. So definitely saving myself a lot of money by using these. So basically, tighten that on there, tighten this nut on this side, which I'm just going to hand tighten right now, and boom, that thing's on there. It's not going anywhere. There hopefully isn't any play, except for I need to tighten the bearing onto the thing I just welded. Anyway, so we got that on, and it's working perfectly. Alright, so unfortunately, I didn't think of this, but this pulley does not line up with that pulley. So unfortunately, I had to tip the lathe over. I'm hoping to God it does not fall, because if it falls, it's going to damage a lot of stuff. So all I gotta do is move this motor down. I have got to drill new holes and tap new holes for this drill. Hopefully I'm able to move it down enough to where this, because this is moved all the way over as much as this can. This thing, pulley, is moved over as much as this can, so I'm gonna have to move the motor over a little bit more. So it's gonna take me a little while to drill these holes. I gotta do it with my hand drill, and it's gonna take me a little while to tap the holes. Alright, so we got the headstock on. Had to buy a new pulley for the motor because the old pulley was too small. I know this is a really big pulley, but this is the only one I had. This is off a lawnmower. It's the only one that I had a flat piece of metal that was big enough to where I could fit it onto this collar to fit it on this giant axle. So I had to get this big pulley, so therefore I had to get a bigger pulley for that side. So, but got the belt on. I got the sensor all hooked up. Had to put a bunch of magnets on the pulley, so therefore the sensor has something to read. It turns. It doesn't trip the sensor to where it stops. It works everything. And now all I need to do now is get that chuck onto here. Basically, take this, surface it so it's completely straight. Also surface this just to make it look better, and figure out where in the world to drill the 3 holes to mount the new, or not the new, to mount the chuck to the new headstock. Alright, so now we got this surface perfect and perfectly lined up, perfectly straight. There's no wobble at all. Now, we have to figure out how in the world to mount the chuck onto here. Now, last time I had a piece sticking out, and I just clamped the chuck onto that, and then just took a piece like this, just a little screw that fits in the holes for the chuck. I ground a point on the end, so therefore when I screw this into the chuck, I line it up. But this time I didn't have anything sticking out, so I just kind of had to hold it there and eyeball it and make, feel that it looked okay. I'm gonna have to do a lot of tuning just to get this thing perfect like I did last time, but it's possible. So I took a hammer, punched a hole, started to drill a hole. Now, unfortunately, I can't take this off and put it in my drill press and drill the holes that way. I'm gonna have to do it by hand, but I figured out, or I thought of a clever way to use the carriage to help me drill the hole. Alright, so basically, instead of me just putting the drill here and using all my strength to push it, I'm using the headstock, taking the headstock up, make sure the drill's lined up evenly, looks pretty straight right there, looks pretty good, and I'm using the carriage to push the drill in. So, safety glasses on, see if this works. Wow, that worked really well. Now, do the proper size of the hole. Line it up, make sure it looks pretty good. Is this drill bit fucked up? No. Had to get it started. Make sure it's lined up again. Constantly having to readjust it. It's level, perfect. Alright, so last night I got the chuck mounted to the headstock. Took me over 2 hours to mount it and to get rid of as much play as I could. So, got the dial caliper set up there. I think that's what you call it. And, let's see how much. There's just a tiny, tiny bit amount of play in the chuck. I mean, that's like what? Like 5/1000ths of an inch? I think. I don't know. I don't know how to read these things. Anyway, that's pretty damn close. And I'm willing to accept that. It took me like an hour and a half just to be able to get that to that point. So, and actually looking at this new headstock makes the chuck look tiny. If you remember the old headstock, it looked minuscule compared to this new one. This thing is awesome. Anyway, let's put a piece of metal in the chuck and set the dial indicator on that. Alright, so let's see how that does. Just a piece of round stock set in there. Again, like almost 5/1000ths of an inch, I think. So not that bad at all. I mean, yes, there is play in there, or yes, it's not perfect, but that's almost perfect. I'm willing to accept that. I can, however, tinker around with it a little more and get it to where it's absolutely perfect. I drilled the holes on here just a little bit bigger, so therefore if I can just loosen these and the chuck moves around a little bit, so I am able to get rid of that. Eventually I will, but for now that is perfect. Now the true test. I have this little carbide insert tool in here. Let's surface this right here and see how well it does. See if there's any chatter in there. It's kind of not a good place to put the camera, but it's the only place. So let's do a face cut on this piece of metal and see how well it does. See if there's any chatter. Alright, let's see how well that did. There was no chatter. If there's any little bit of chatter, it's in the carriage, which I still need to improve. Huh. Not perfect. It's not as perfect as I was hoping, but still, that's a lot better than it was with the old headstock. I call that a success. I like it. Alright, so it didn't do that great of a cut, but I don't know. Can you guys even see it? There we go. I mean, there's still a little bit of pitting. It's still a not perfect cut, but for something homemade, I'm willing to accept that as pretty decent. I don't know. We got rid of the chatter, I know that. We got rid of the chatter in the headstock. There's still a little bit of chatter in the carriage, which we need to figure out and deal with. I did have to add another 1/2-inch piece of plate in between the compound slide and the tool holder. Well, what I'm going to eventually do is cut another piece of metal the size of this, add it here, and then mount the compound slide to that and have it differently to where instead of clamping it down, it pushes it up. I'm going to have it clamp down and push it down. So that is why I added another 1/2 inch to this. So therefore I can do that. And I can also eventually, if I want to, rebuild my compound slide to something bigger and a lot more strong. Right now, it's a little bit tall and really thin, so I kind of want to rebuild it. It's not perfect. There is a little bit of a chatter in there. If the cutter doesn't want to cut, I can just see this thing bending this way. So I do eventually want to rebuild this, but for now, this piece of plate right here raises it up to what it needs to be for now. So for now, it works, and I'm gonna end the video right here because I know this video has probably been long enough, and I know I've been working on this thing for you know, just rebuilding the headstock. It's taken me like a week and a half to 2 weeks. Anyway, I'm going to end the video right here. Thank you for watching, subscribe, and have a nice day.